lectures on finite element analysis. In finite element analysis, first topic is problem solving, means how to solve your engineering problem. Okay, start with introduction. Engineering must be analyzed and solve a wide range of technical problems. Some will be responsible single solution problem and other are the open-ended problem. Okay, means some problem are simple in nature, some problem are complicated in nature. Okay, step by step we go for the next. Problem solving involves experience, knowledge, process and arts. Okay, in which we have to focus on computer aided problem solving methods. Okay, computers are good to solve the problems, in which computers have itself some software. That software is used to solve your problem. Some kind of engineering problems require a science and some says it's required the arts. But for engineering problem, we require the combination of science and combination of art. Both are very essential and very useful to solve the engineering problem. In science, there will be mathematics, physics, chemistry, mechanics, and in arts, it's a judgment, experience, then common sense, and know how it is working, how it is going to the run that machine. That are the main important things to solve the problem. Engineering methods. Okay, recognize and understand the problem, gather the data, select guiding theories and principles, make assumption when necessary, solve the problem, verify the result and present the solution. In means, in problem solving by engineering method, you have to recognize and understand the problem, recognize and understand what is the exactly problem, what is the exact problem, then gather the data, means gather the input, what are the givens, means it is a force, it is a friction, it is a some temperature from outside to the that body. That's are the gathering that data, basic, what are the given data in situations, then in physical data, in chemical data, in temperature data. That's any type of data, gather the data, select guidelines, theory and principle, select what are the theories used for this solving that problem, principles, what are the thumb rules, what are the principle to solve that problem, make assumption when necessary. If you require to make some assumption, then you have to make a assumption, then solve the problem, means actual solution of that problem. Okay, solve that problem, verify the result will be verified with other ones. Okay, not only one method you get the result, you can check this result by other method also. Okay, then last one is present the solution. If your solution is verified and it is tested, it is okay, then presented that solution to your higher authority. These are the engineering problem solving methods. Types of engineering problem: creative, new project or cost reduction. Both are the types of engineering problem. First one is create new product, means you have to innovate, or conceptualization means new concept development or new modification of your product. Okay, or you can make a new product. And second one is cost reduction. Cost reduction means you can do the same product or same model or same any equipment with the very fast in time, cheaper in rate or better in result. Okay, here example is a personal computer. Personal computer you have to reduce by cost by any time or better to perform. You can optimize your personal computer by using this. Next, development or change the procedure. Example, warehouse inventory. Okay, it means develop and change the procedure. Problem solving type. It means if you require, firstly you instead of 3 months inventory means you have to stock up 3 months. But if you optimize that stock or optimize the cost behind that stock, then you go for the just in time. Just in time means if you get the order from your customer, then you go for the factory and call that this product is required to customer, and then you give time to that customer. You get your product in 3 days, 4 days. Just like you see the Amazon, if you click on any product in Amazon, Amazon give you a preferable time, means in what time you get that product. Then they will be called to the supplier of that product. This supplier of that product call to the exact manufacturer of that product, and then they get you 7 days time is required, 9 days time is required, or within 1 day, within 2 day your product will be delivered to your location. Okay, this is called as a just in time, means when you require, then you call the product. Okay, then human factors means reduction of your human factors, means reduction in manpower. It gives the again a better result for the problem solving. Or last one is the add of new features, means you have to not change the current design, means base design is same, but you can only change few things to get the better result. Okay, next, what is the exactly problem solving types? Givens, operations, goal, problem state, and solution. Means given, the initial condition of problem. Operation means what are the action you required to do on that problem. Okay, goals means what are the desired output of your problem, means what are you think it is our goal, it is our solution, final solution. Problem state means vary any specific point to point or point to point layout of your problem with a specific time. Okay, means from start of your problem to the end of your problem or end of your solution, you get the point to point data. It means problem state. And last one is a solution. Solution is a completely specify all operations or your goals will be satisfied, and all problem state means how to get that problem is solved. All problem state will be involved in your solution. Okay, these are the engineering problems. We only consider the engineering problem, how to solve the engineering problem, how what are the tips to solve the engineering problem. Okay, next one, steps in a problem solving. Identify the problem, determine what required for the solution, means identify. Fix the problem, what you have to do or what you have to not do, means fix the problem. Then determine what is requirement of your solution. First one is what is the known value, what is the unknown value, means what are the known value. If you solve the stress problem, means you have to solve the cantilever beam, then known is a your force, your length of that part, then size of that part, shape of that part, material of that part. What are the unknown? Unknown means where it is a exactly what are the extra forces coming to that, coming for, you have to require the extra forces, means extra forces or some temperature or some environmental changes. It's unknown things. Okay, known things is a force, then shape of that part, size of that part. Okay, then any special cases in this, means any special cases in that problem, then any limitation for that problem, means a definition. What are the exactly definition to require or to solve that problem to get the best result. Okay, develop a step by step plan, means develop any algorithm to solve that problem. Okay, then outline of the solution with a logical diagram, means you get the basic outline of your solution, means how you get the result or what are the result you want to get. Okay, and last one is execute the plan. Keep the track what are the work is going on or what does you have to done or what you have to not done, and then execute the plan step by step towards the solution. Means problem is the first step of your solution, and last step of solution is your solution with all intermediate step. Okay, then next is the types of FEA analysis. Okay, FEA analysis results are determine the various types of results in FEA. Okay, in that type of analysis depends on the result we want to obtain. Means type of analysis means you want to obtain a temperature result, it's a thermal analysis. You want to obtain the stress strain, it's a static analysis. If you want to obtain the temperature result with the effect of time, it's a transient thermal analysis. If you want a result with a time dependent only with force and your other factors, then it is a dynamic analysis. If you want result of your vibration, it's a modal analysis. These are the various types of analysis. Means if FEA solve your problem, then FEA is divided into many of the problem. It is a CFD problem, it is a static problem, it is a dynamic problem, it's a thermal problem, it's a transient thermal problem, it's a modal solution, it's a vibration, it's a magnetic, or it's a electronic solution. These are the types of FEA problem. Okay, FEA problem is depend on how or what you want to get in solution. If solution is changed, then problem is changed. Type of problem is changed. Means if you want a temperature result, it get the thermal analysis. If you want a stress strain result, it give a static analysis. Okay. These are the types of FEA analysis. Then studying non-linear or linear problem. Okay. What is meant by linear? Stress is directly proportional to strain. Okay. It's a linear problem. Some are the non-linear problem. Means stress is not directly proportional to your strain. These are the non-linear problem. Means if you take an example of cantilever beam, it is a made up of steel. Then it is a go for the stress is directly proportional to strain. It's under the linear problem. If the cantilever beam is made up of rubber or made up of any non-linear material, just like carbon fiber, glass fiber, or rubber product, it goes the non-linear in nature. That's why the problem is a non-linear in nature. It's a non-linear problem. If the material of a stress strain curve, then it's a linear problem or linear material that go under the linear problem. Okay. Next one is static problem or dynamic problem. Means static problem means there is a very simple or solution you get in a static problem. Okay. If you go for the dynamic problem, there will be time consideration, and in time consideration there will be surrounding or that system in that problem is maybe changes depends on time, and it is difficult to get the solution in dynamic problem. Okay, means in static problem time is a very slow in nature, or you can neglect that problem. But in dynamic, time consideration is very important, and due to the time consideration, it takes a difficult to solve that problem. Okay. Next one is quality and detail of your CAD model. If your CAD model means for FEA, you required ANSYS software. Okay. And for CAD, you required a CATIA software. Means in CAD model, you can make a 3D model of your any environment. Okay. Then it's import in ANSYS. Means CATIA model is import in ANSYS for a FEA analysis. But due to some issue, the CATIA model is not directly or not fully recover in ANSYS. Then it's a geometric losses in CATIA model, in CAD model. Or these geometric losses you cannot converted because of this geometric losses. You cannot converted your model into the mathematical model or accurate mathematical models. It means you cannot mesh or you cannot divided this whole part into FEA, means finite element, for a analysis purpose. For this, you require a quality CAD model, means there will be no any geometric losses happen between conversion of CATIA model into ANSYS model. Okay. If this model is very small, then it doesn't go for the any geometric losses. But it is a very big assembly, big structure, then it go for the geometric losses, and it is not accurate for the mathematical modeling in ANSYS or analysis. It means a FEA. ANSYS means it is a platform to solve the FEA problem. It's a ANSYS. Okay. That's why CAD model is also good or in better quality to solve the any FEA problem. Okay. Thank you so much. In this lecture, we study that what are the problem solving steps, means from starting to the solution, what are the steps to solve the problem, any mathematical or any engineering problem. Okay. Next one is what are the FEA problem, means FEA problem is divided into many types. It is depend on the solution, or FEA problem is depends on the solution condition, means temperature or static result you want to require, or dynamic result you want to require, or transient thermal you are going to require. That's why different types of FEA problems are there. Then next one is what is the CAD model and why it is important. Because CAD model is important to solve the FEA problem. But if CAD model getting the geometric losses to convert in CAD into FEA model, then it is a hamper your result, or it cannot be give a actual or better mathematical model. Okay. So you have to require a best quality CAD model. Okay. In next lecture, we study about the basic concept of FEA, means what is the meshing, what is the your element, what are the nodes, how it is the main model is converted into FEA, means mathematical modeling of FEA. Okay. Thank you. Thank you for watching.